Okay, this is the chapter review, chapter 5 review or study guide for upcoming tests. This is 2024, November 2024. Okay, also posted on Google Classroom is the key that you can look at, but this one I'll be going over each of the problems and going over how to do those. Okay, so this we're going to solve each system by graphing, and we know that when we graph the two linear equations, that where they intersect is our solution. So we're going to graph both of these. These are in standard form, so you can do x and y intercept from standard form. I only like to do it if it's a integer, not a decimal. Or you can put it in slope-intercept form. If you remember, to find your x-intercept, you divide it by the coefficient of x. To find your y-intercept, you divide it by the coefficient of y. So this, my x-intercept would be 2 divided by 1, or 2, and my y-intercept would also be 2 divided by positive 1, so 2. So you could graph it this way, and you can kind of see, if you look at those 2 points, go down 2 and to the right 1, that it has a -1 slope. So you could go ahead and graph some more points out that way. The other way, of course, is that you could put it in slope-intercept form and graph it that way. If this was slope-intercept form, I'd just bring this x over and do the opposite and subtract it. So it'd be -1x plus 2. Y-intercept's 2, down 1 to the right 1, and draw your points. All right, for the second equation, if you had -y equals -x plus 4, divide by -1, so y would equal x minus 4. So y-intercept is at -4, and slope is +1. So we would continue going up that way, or the opposite, and graph our line. And we can see that they intersect at the point 3, -1. So 3, -1 would be our solution. That is our intersection. So that is the place where both equations have the x value of 3 and the x value of -1. So if I plug those in, 3 minus 1 equals 2. Yes, it does. And 3 minus -1 equals 2. Yes, it does. No, I mean 4. Excuse me. I was saying, no, it doesn't. Yes, it does. All right, number 2. And I think for consistency, I don't know, I'm going to go back and forth with slope-intercept and standard. Here, this one, standard form, I can see if I do x and y intercepts, it'll work pretty good. The only problem is that those middle points in the graph, you might not have them exact, but we'll kind of play with that a little bit. So this one, my x-intercept be 15 divided by 3 is 5. My y-intercept would be 15 divided by -5 is -3. So -3 and 1, 2, 3, 4, 5. So we're looking at the slope here. So this, I went down 3 and to the right 5. So I could do that again. Down 3 or went up 3 to the right 5, or down 3 to the left 5, excuse me. You draw your line across that way. Here, y equals 2x plus 4, so we go to 4. My slope is 2, up 2 to the right 1, or do the opposite, down 2 to the left 1. Keep going, keep going, keep going. So we see where they're crossing, they're intersecting here at -5, -6. So that's going to be our solution. I'm going to put this one in slope-intercept form. I'm going to bring that x over. And so now I have -4y equals -x plus 28. And we're going to divide by -4 everything. Don't forget the sign in front of the coefficient of y. So this will be y equals negative divided by negative is positive 1/4 x plus 7. So 2, 4, 6, 7. And go up 1 to the right 4. Or I can do the opposite, down 1 to the left 4. So there's my line. And then the second equation here be 2y equals -x minus 2. I just brought that over. Then divide by 2. So y equals -1/2 x minus 1. So -1. So you can go down 1 to the right 2. And you keep carrying that out. Or you can do the opposite, up 1 to the left 2. And carry that out. And you know what? This is going to be off of the graph. Did I do that correctly? Okay, y'all. Miss Lane makes mistakes. Trying to do this too quick. We divided by -4 there, right? My bad. Okay, so we divided by -4 right here. So this should be -7. So let's erase this crazy line here. Let's regraph this line. So we are at -7. So 1, 2, 3, 4, 5, 6, 7. Go up 1 to the left 4, right 4, up 1 to the right 4. So we're intersecting right there. There. I was getting worried. I was like, okay, we don't have an intersection. So our intersection is here at 8, -5. Better. That's what you get when you go too fast, y'all. All right, this one we're going to divide by 3. So y equals 4 divided by 3x, and then -6 divided by 3 is -2. So -2 is y-intercept, up 4 to the right 3, up 4 to the right 3, or go down 4 to the left 3. My eyes are starting to cross. Look at these little lines. Sad when y'all get old. Can't see. And for our second equation, I'm going to bring this 8x over and do the opposite and subtract. So I got -6y equals -8x minus 30. And I'm going to divide by -6. So this will be y negative divided by negative is positive 4/3 x. Just simplified that fraction, y'all. And this would be -30 divided by -6 is positive 5. So we're going to go up 5 my y-intercept. So my slope is positive 4 over 3, which 4 over 3 would be about here. We can do the opposite and go down 4 to the left 3. Down 4 to the left 3. Now tell me, did you notice anything about these two equations? Well, if you look at the lines, they kind of look parallel, don't they? And if we look at the slopes, they're the same. So they are parallel, and we know that parallel lines have no solution to them. Okay. All right, and number 5, it says solve each system's equation by substitution. Okay, we know that substitution, we need to get a variable, at least one of the equations with a variable by itself. So they both have the variable by itself, so we're lucky there. So this one says y equals this. So I'm going to take this and substitute this y with it. So 2x plus 3 equals, my other part of my equation was that. So we're going to bring this over and add x, and we're going to take the 3 and put it to the other side. So this cancels. So I have 3x equals, this is gone, negative 9 minus 3 is negative 12. Divide by 3, x is negative 4. All right, so now I know what x is. I can plug it in either one of the equations and find out what y is. So 2 times, I'm substituting negative 4 for x, plus 3. So y equals negative 8 plus 3. So y is negative 5. So we know what our x and y coordinates are now. So our answer is the ordered pair. X is first, negative 4, negative 5. Because this would be, if I was to graph these two lines, this would be the intersection point. This is where both equations have the same x and y value. All right, number 6. This one we only have one of them where y is a variable by itself. So we're going to substitute this for this y. So we're going to 2x plus 3 times y. So 3 times 5x minus 27 equals 4. So we're going to just distribute it out. So it'd be 15x minus, what is 3 times 27 is 81. Okay, so we're all on the same side here. So we're just going to combine our like terms. So I got 2 x's plus 15 more of them would be 17 x's. So now I just have a simple two-step equation. So I'm going to solve that and isolate the variable x. So we're going to add 8 to both sides, get rid of it. 17x equals 12. And then we're going to divide. Oh, I forgot my 1, didn't I? It's not 8, it's 81. So this is 85. Divide by 17. So x equals 5. So now I can take that and plug it in either equation to find out what y is. So 5 times x, or 5 times 5, minus 27. So it'd be 25 minus 27 is negative 2. So my solution is the ordered pair 5, negative 2. Remember, x comes first. It's a point on your graph. All right, good deal. All right, let's look at the next page on your study guide. So All right, number 7. All right, neither one of them have the variable isolated, so we need to isolate at least one of them. So I'm going to take this 2y here, and I'm going to move it over here and say plus 2y. So now we got x equals 1 plus 2y. So I'm going to take this and substitute it for that x. So 1 plus 2y for x, and then plus 4y equals 19, because that's why they call it substitution. We're just plugging stuff in. So combine your like terms. So 1 plus 6y equals 19, and then we're going to subtract 1. 6y equals 18. Divide by 6, so y equals 3. So now I can plug it in any equation, and let's just plug it in this one. All right, so I'm replacing y with 3. So x equals 1 plus 6, so x is 7. So my solution is the ordered pair 7, 3. All right, number 8. And y'all, a lot of times for reviewing your studying, you can stop the video, work number 8, and then see if you got the same thing I got. All right, y, I want a positive y, so I'm going to swap places with those two, and I'm going to have y equals 6x plus 21. So now I'm going to substitute it for this y. So 5x plus 3 times y, or 3 times 6x plus 21, equals 17. So distribute the 3, so we get 18x plus 63 equals 17. Combine your like terms. 18 plus 5 is 23x plus 63 equals 17. And now we just solve for x. So minus 63 minus 63. Don't go so quickly that you don't pay attention to your signs. 17 minus 63 is negative 46. So we're dividing by the coefficient of x. So x is negative 2. So now I can take the negative 2 and plug it in here. So y equals 6 times negative 2 plus 21. So negative 12 plus 21 is 9. So my solution is the ordered pair of negative 2, 9. All right, the next one says solve the system by elimination. Okay, so elimination is we need to line up my x's, line up my y's, line up my equal signs, and then line up the constants. So they need to be on top of each other. If they're not, we need to move stuff around to where they are, okay? So once you have that, then you say, okay, do the x or y, do they have the same coefficient? Well, neither one of them does. And what I need is to have like a negative x and a positive x, like 2x and negative 2x, so that I can eliminate them, okay? So I'm going to try the x's. So I got positive 3 here, so I need this to be negative 3. So I'm going to multiply the entire equation by negative 3. So that gives me negative 3x. Negative 3 times negative 3 is positive 9. Y. Bring down your equal sign, Negative 3 times negative 13 is positive 39. Okay, so now these are this equation, we're done with it. So now these are my two equations, and I'm going to add them together. And when I do that, I can eliminate one of my variables. That's the goal, is be able to eliminate one of your variables. So now 7y plus 9y is 16y equals 25 plus 39 is 50, 64. So y, when I divide, y equals 4. Now I can go back and plug in 4 for y in either one of my equations. I'm going to plug it in that first original one there. So x minus 12 equals negative 13. If I add 12, I get x equals negative 1. So my solution is the ordered pair, negative 1, 4. Okay, again, you can pause, work the problem out, and then see if we match up. All right, I can either make the 8 and 20 the same, it'd be multiples, right? Or I can do 2 and 5. So let's multiply this one by 5. Remember, one of them needs to be negative, so we'll make negative 2. So now my new equations, distribute this 5 with everything. 10x plus 40y equals 30. And then multiply negative 2 with everything. Negative 10x minus 40y equals negative 30. Wow, y'all, we eliminated everything on that one. So all we're left with is 0 equals 0. So this is one of those special cases whenever you eliminate your variables and you're just left with constants. If it's true, then it's going to be infinite solutions, okay? If it said like 0 equals 4, then that would be false and you would have no solution, okay? And this is special cases. It's only if we eliminate our variables, okay? All right. Number 11. All right, let's just bring this y over here and bring the 19 over here. So y equals 7x minus 19. Oh, I'm trying to do substitution. My bad, y'all. My bad. Okay. We got a negative 3 here. Let's go for a positive 3 here. So we're going to make that negative 1 a positive 3, we need to multiply by negative 3. So we'll have negative 21x plus 3y equals negative 3 times 19 is what? 57? Okay. So now this one's gone, and we're going to add these two together. So 2 minus 21x, 2x minus 21x will give you negative 19x. These are eliminated, equals 19 plus 57 would be 76, right? It's one of those negative, oh, my bad. That's a negative 57. Y'all didn't stop me. Negative 3 times negative y was positive 3y. Negative 3 times negative is negative 57. So now, 19 minus 57 is negative 38. And then we divide by negative 19. We get x equals 2. So now I can plug that in any equation. So let's just say 2 times x, or 2 minus 3y is 19. So this is 4. So we're going to subtract 4 over here. So negative 3y equals 15. So y equals negative 5. So solution is negative 5. Oops, x first, Karen. So 2, negative 5. Number 12. These aren't lined up, are they? So we need to get them lined up. This has got x and y on one side, number on the other, which is standard form. Let's put this one in standard form. Let's bring this 2y over here. So now we got 4x minus y equals negative 4. And then 5x minus 2y equals 1. All right, so now we need to eliminate. So let's multiply this by negative 2. So my new equation will be negative 2 times 4x is negative 8x. Negative 2 times negative y is positive 2y. Negative 2 times negative 4 is positive 8. So I'm going to add these together. 5 plus negative 8 is negative 3x. Eliminate equals 1 plus 8 is 9. So x equals negative 3. And then I'm going to plug that into either equation. So 5x, so 5 times negative 3 equals 2y plus 1. So negative 8 equals 2y plus 1. So I'm going to subtract 1. Okay, and wait a minute. 5 times negative 3 is negative 15 equals 2y plus 1. Minus 1, minus 1. So negative 16 equals 2y. So negative 8 equals y. So my solution, negative 3, negative 8. Okay. All right. Oh, word problems. Yay. Okay. So that this video is not forever, we're going to work. Let's just work the odd ones on this, okay? And I'll give you the answers to the even ones. All right, so a tennis coach took his team out for lunch and bought 8 hamburgers and 5 fries for $24. Players are still hungry, so the coach bought 6 more hamburgers and 2 more fries for $16.60. Find the cost for 1 hamburger. Okay, so we need to define. Let's just say that X is the cost of a hamburger. It's real important that you identify this. It's the cost of a hamburger. And Y is the cost of fries. All right, so when the first time he went up there, he bought 8 hamburgers. So 8 times the cost of hamburgers. That'll tell you how much money he spent on hamburgers. Plus 5 fries. So 5 times the cost of fries will tell you how much he spent on fries. And he spent what he spent on hamburgers and what he spent on fries totaled $24. Our second time he went up there, he bought 6 hamburgers and 2 more fries for 1660. So there's our equation. So now we need to come up with the same coefficients, 1 plus and 1 minus. So you could do 5 and 2 for 10, or 6 and 8 for 24. So let's do 24. And you could do 10, doesn't matter. I'm going to do 24. So 3 times 8 is 24, and 4 times 6, I'm going to make this negative 24. Okay? So my new equations, when I distribute these out, 3 times 8 is 24x plus 15y. And remember to distribute it everywhere. So that's what, 72? And then that'll be negative 24x, negative or minus 8y. And then negative 4 times 1660. I'm going to get the calculator. Be $66.40. Okay, so now we got 1 plus and 1 minus, so we can add these together. So this cancels out. 15 plus negative 8 is going to be, what, 7y equals 72 plus, and this is negative, 72 minus 66.40 is $5.60. Divide that by 7. So my fries are 80 cents each. All right, so that's how much the fries are. I need to know how much the hamburgers are. So I'm going to plug in 80 cents for y. So if I say 8x plus 5 times 0.80 equals 24. If I work that out, I get x equals 250. So they wanted to know how much it costs for one hamburger. $2.50. All right, number 14. You're going to let x equal hot dogs and y equals steak. And you've got the key on Google Classroom, so you can look at that, but they wanted to know how many steak sandwiches did he sell. So he sold 634 steak sandwiches. Okay, 634. All right, the next odd one here. We're going to do this one. Bob bought 24 hockey tickets for $83. Adult tickets cost $5.50. Child tickets were $2. How many child tickets did he buy? So we're going to say that adult tickets, the number of adult tickets is X, and the number of child tickets is Y. So $5.50 times the number of adult tickets plus $2 times the number of child tickets equals your total he spent of $83. And you say, okay, well, that's just one equation. Well, what else do we know about adult tickets and child tickets? Well, he had 24 total tickets, right? So let's say X plus Y equals 24. Okay, so now let's eliminate. I like dealing with whole numbers instead of decimals, so we're just going to multiply this by -2. So I get -2x minus 2y equals -48. So now we're going to add my two remaining. So 550 minus 2 is going to be 3.50x. My y's eliminate. 83 minus 48 is going to be 48, 50, 33, 35. So X is going to be 10. And if I plug in, X is number of adult, right? So if he had 10 adult tickets and he had a total of 24 tickets and he had 14 childs tickets. And if you wanted to verify, you could plug in 10 for X and find out what. So 10 plus Y equals 24. 24 minus 10 is 14. All right, number 16, I'm not going to do that one, but the answer is 4 hours mowing. Number 17, Dustin has only nickels and quarters in his piggy bank. Oh, I'm glad we're doing one like this. So he only has nickels and quarters. He has 49 coins total. So let's make nickels X, nickels X, the number of quarters Y. So he only has 49 coins, so X plus Y equals 49. All right, and the total equals $8.85. So the total's $8.85. You say, well, wait a minute. I only have an X and Y. They didn't give me anything else. Well, this is money, right? So I'm trying to find, and X is the number of nickels. So I need to know how much a nickel's worth. Well, how much is a nickel worth? It's worth 5 cents. How much is a quarter worth? 25 cents. So now you have your equation. Okay? So if I want to eliminate, I can multiply this by negative 0.5. So I got negative 0.5, or 0.05x minus 0.05y equals, what is 49 times 0.05 is 245, negative 2.45. So if I add those together, that eliminates. 0.25 minus 0.05 is 0.20y. 885 minus 245 is 640. And then if I divide that by 0.20, then I'm going to get y equals 32. So he had 32 quarters. And we know he had 49 coins, right? So 49 minus 32 would be 17 nickels. Yay. Okay, because we know he had 49 total coins, and they were only nickels and quarters. So if we take away the quarters, leaves us 17 nickels. All right. So let's do a little bit of graphing here, inequalities. So let's graph this one. All right, I'm going to use X and Y intercept because I don't need to know exact every point. So for my x-intercept is 6 divided by the coefficient of x. So my x-intercept, these are kind of light here. So this is my x, and this is my y. All right, so my x-intercept is 3. And then my y-intercept is 6 divided by the coefficient of y, negative 3. So my y-intercept is negative 2. Now, this is going to be a dashed line. So we can do dash. Now we need to find out where we're going to shade. It says that it's less than. So this is under the line. But let me ask you something. What you have to be careful with is inequalities. So if you know your variable is going to be divided by negative. So if I was going to put this in slope-intercept form, negative 3y is less than 6 minus 2x, and then you divide it by negative 3. If I'm dividing that variable by negative, I got to reverse that sign, don't I? So this would be 2/3 x minus 2. Okay? So sometimes just looking to see above or below the line, always do a test point. And I said in class, if 0, 0, your origin is open, it's not on the line, use it as your test point. So I'm going to replace x and y with zeros. So is 0 less than 6? Yes, it is. That's true. So this point is a solution. So that means all of my solutions are over here. Okay? So you have to be careful with inequalities because sometimes you got to flip that sign whenever you're dividing your variable or multiplying your variable by negative, okay? So be careful with that. Easiest way is always use that test point. All right, this one, x is greater than or equal to negative 3. So this is a special line. It's either going to be vertical or horizontal. So it says this line's going to cross x at negative 3. So if it's crossing x, it's going up and down. So at negative 3, so we're going to cross that line, and it's going to be a solid line because it's r equal to. Oh, my lines. All right, so this is all my solutions are greater than or equal to negative 3. So on this number line, everything greater than or equal to negative 3 is over here. I can also plug in 0. 0 greater than negative 3. Yes, it is. It's true. All right, so let's graph a system of inequalities. So we're going to graph two lines, and we're going to find the intersection of both their shadings. Okay, so let's graph this one first. My y-intercept's negative 2, slope is 3. So I'll go to negative 2, up 3 to the right 1. Okay. Or down 3 to the left 1. And it's less than, so it's going to be a dash line. Okay. Now my shading, it's not touching 0, 0. Almost is. But let's just plug in. 0 is less than 0 minus 2. So 0 is less than negative 2? No, it's not. So we're going to say it is on this side. So we're just going to kind of draw some little lines here. Okay. So now let's look at the next equation. Y is greater than x, negative x plus 3. So we're going to go to positive 3. The slope is negative 1. So down 1 to the left 1. Okay, this one's also going to be dash. So we're just going to try to draw that out a little bit. Here, 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 here. So this is my dash line. So now, it's not in 0, 0, so we can plug in 0 is greater than 0 plus 3. 0 is greater than 3. Well, that's false. So this would be false, so Miss Lane is having problems today. It's a negative slope, not a positive slope. Okay. Let me get my life together, y'all. All right, plus 3. Slope is -1, down 1 to the right 1. So we're going this way. All right, so it's going to be a dashed line, so we're just going to do part of it. All right, so 0, 0 is not greater than 3, so this is false, this side, so it's going to be this side. So now, we say, okay, where is it red and black? So it would just be right in here, using those dashed lines as our boundaries. We're not touching those lines, but we're using the dashed lines as our boundaries. So everything in here would be my solution. Okay? All right, let's try 21. Let's see if Miss Lane can graph a line. All right, so let's put this in slope-intercept form. Negative y greater than or equal to negative 2x plus 0. I'm not going to do the plus 0. Divide by -1. Dividing my variable by negative makes me reverse my sign. So y is less than or equal to 2x. So my y-intercept is at 0. My slope is positive 2, up 2 to the right 1. Is this going to be a solid or dashed line? Well, since it has that r equal to, that means we're including every point on that line, so it will be solid. So now 0, 0 is not open, so I'm going to have to pick another line for a test point, or another point. So let's just pick, we can pick 1, 1. It's not quite on the line. So 1 is less than 2 times 1. Well, that's true. So that means 1, 1's true. So that means everything on this side of the line is a solution for that inequality. For our next inequality, we're going to bring this over and say minus 3x. So y is less than negative 3x plus 5. So 5, 2, 4, 5 is my y-intercept. My slope is negative 3, so I'm going down 3 to the right 1. Down 3 to the right 1. And repeat. And I can go up 3 and to the left 1. So this is less than. So we're going to do dash line. Okay. And we can use the point 0, 0. So 3 times 0 plus 0 is less than 5. Yes, 0 is less than 5. That's true. So now this is everywhere this way. So my solutions lie in this area where both red and blue were drawn. So we're looking right here. Everything in here. So this is my solution. All of my solutions are in there. All right, and the last last one. Woohoo! All right. Rob works part-time at the Fallbrook Riding Stable. He makes $5 an hour exercising horses, $10 an hour cleaning stalls. Blech. Because he's a full-time student, he can work no more than 12 hours per week. However, he must make at least $60 per week. All right, so we got a systems of inequalities. So the information we got, one of them's dealing with how many hours he can work. The other one's dealing with how much money. So let's talk about the hours first. We said that he can work no more than 12 hours. So if we say X is the number of hours for horses, and then Y is your number of hours cleaning, okay? So if he works X plus Y hours, he's no more than, so that means less than or equal to 12 hours per week. Now he needs to make at least 60. So does he need to make more than 60 or less than 60? More than, so greater than or equal to 60. So the money he makes from exercising the horses, and then the money he makes for exercising the cleaning the stalls. So the money he makes is $5 for the exercising the horses and $10 for the stalls. So there's our two equations. Okay, all right, so we've got our two equations, and we need to graph these now. We could really use x and y intercept. So my x-intercept be 12 divided by 1, the coefficient of x. So my x-intercept is 12, and my y-intercept is 12. So 2, 4, 6, 8, 10, 12. My x-intercept, 2, 4, 6, 8, 10, 12. And y'all, when you're graphing and you're just really looking at, you're not quite looking at for the exact point of intersection, but you're looking at shading, it might prove to be easier just to graph your x and y intercept. Okay, so there's that one, this one. So my x-intercept would be 60 divided by the coefficient. So this would be 12. So your x-intercept on this one's the same thing. And then your y-intercept, 60 divided by the coefficient. So it'd be 6. So 2, 4, 6. So this would be my second. All right, so let's look back up here at my first one.
Cafeteria.
Let's use the test point 0, 0. Like I said, if it's not on the line, I'm going to use 0, 0. So 0 plus 0 is less than 12. Yes, it is. So that means everything this way is a solution for that line. For this equation, 0 plus 0, 5 times 0, 0, 10 times 0, 0 is greater than or equal to 60. Well, no, it's not. So it's going this way. So all of my solutions are going to be in between here, where it's red and black. Okay? And then it says write 2 possible solutions. Well, all of my solutions are in this little area, so I can pick any point here. Here would be a solution, here would be a solution, here would be a solution. So I'm just going to say 2, 8. That would be a solution. So he could do 2 hours of exercising and 8 hours cleaning. If he did that, he would work less than 20 hours and make more, at least $60. Another solution would be like 5, 5. And you could put any point in that area, okay? So 5 hours exercising and 5 hours cleaning. Okay, those are just 2 examples. But anything, any ordered pair in this double shaded area. Okay. All right, that was a pretty intense, several examples of the type of questions that'll be on your test. Your test, of course, will not be this long, but you can expect at least 1 or 2 from each of those sections. So, 1 or 2 solving by graphing, and 1 or 2 solving elimination, 1 or 2 substitution, and then 1 or 2 graphing inequalities, and 1 or 2 word problems. Okay? All right. Y'all have a good evening. Thanks.